Hi, this is Stephen Brower from Maryland Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is the final of 3 videos going through a demo of Booth's algorithm. And so the first video showed the determining of, well, we wanted to use Q as minus 13. So this was coming up, the bits what minus 13 were. We wanted our M to be a positive 19. So we figured out, okay, this is the M. We knew we were going to be doing steps like this later. So we figured out the negative M, which is the complement of M, which was this. We then did the initial setup. So the first video got just through the initialization. The second video then went steps 1 through 6. And remember, for a step, we look at Q0 and Q minus 1. Based on those bits, we decide, it's decided what to do. In the case of 1, 0, we subtract M, so we can add M. In the case where you have 1, 1, you just do a shift. And in the case of 0, 1, we add M. So the prior video got us up to this point right here. And what I want to do is let's analyze what we came up with. The result is A and Q. And by the way, comparing this to real life, if we take 32 bits and multiply 32 bits, we'd have 64 bits. So imagine if Q was 32 bits and A was 32 bits, and we did the multiplication, we would end up with 32 bits here, 32 bits here, 64 bits. If we're talking about the computer, this would be EAX. This would be EDX. So I'm just relating it to what we're seeing in the assembly. That's how it relates. Okay, so I want to analyze this thing right here, and I made a copy over here. I want to analyze this right here. Because this leftmost bit is a 1, that means this is a negative number. Well, what I can do is I can apply the 2's complement in order for then figure out what it's a negative number of. So let me apply the 2's complement, of which, the first step is flipping the bits. So wherever there's a 0, we'll have a 1. Wherever there's a 1, we'll have a 0. And then we add 1. Plus 1. So 1 and 0 is 1. There's no carry, so these other numbers will just, in terms of the add, we'll end up with those numbers. Okay. And so again, we're trying to figure out this number right here, which is a negative number because of the 1 here. It's a negative number of what? Well, it's a negative number of this. And so if we figure out, again, trying to figure out what this number is, so 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, which will be 0, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. And so adding just where we have those 1s, so the 2 to the 7 is 128. The 2 to the 6 is 64. The 2 to the 5 is 32. The 2 to the 4 is 16. The 2 squared is 4. 2 to the 1 is 2. 2 to the 0 is 1. And so we're adding 128, 64, 32, 16, 4, 2, and 1. But I'm doing what I would do on the board, which I know it seems silly, but so let's do some pairing. So the 4 and the 6 is 10. The 8 and the 2 is 10. So that's 10, 20, 4, 6, 7, so 27. So 7, carry the 2. 1, 2, 3, 4, and 6 is 10. 13, 14. So 4 carry the 1. So 1 and 1 is 2. So this number here is 247. That means negative 247 was the result that we had, the negative 247. Okay. But wait, what were we doing from the very beginning? Minus 13 and 19. So if we, just to double check, if we take our minus 13 and our 19, 9 times 3 is 27, so 7 carry the 2. 9 times 1 is 9, and then we have 11. 1 times, and so this is the 13, and so 7, 4, 2, and because a negative times a positive is a negative, oh my God, it actually had worked. I'm sorry if I'm so happy about it, but believe it or not, I screwed it up in the rehearsals. So I'm very relieved that I actually got this one right. And by the way, in terms of going into the classroom, I actually would do my rehearsals before going into the classroom and then go in the classroom. If you're off by a bit, it can really mess this whole thing up. But what was the point? Go to the very beginning again. So we wanted to take minus 13, which is this, and multiply it by the 19, which is this. So we're taking this bit stream, multiplying it by this bit stream, using Booth's algorithm. So the negative 13 is our Q. Our positive 19 is our M. We initialize the A and the Q minus 1 to 0. And then for each step, it was looking at Q0 and Q minus 1. And by the way, there's another video that gives the overview for Booth's algorithm, talking about being like a sum of products, which, anyway, so, oh, God, the sum of products, which, by the way, that's what happened here. We had partial products. The 9 times the 13, that was the 117. The 1 times the 13, that was the 13. We added the products together. There was our sum of our products. And the Booth's algorithm is kind of working the same way, except we're dealing with zeros and ones. So, again, the final, after the result of step 6, if we have 6 bits, there's 6 steps, 4 bits, 4 steps, 32 bits, 32 steps. The result of the last step, the A is the upper bits, the Q is the lower bits. So for 6 bits times 6 bits, we have 12 bits. The upper 6 being an A, the lower 6 being a Q. Since the leftmost bit is 1, that's negative. And so what I just did is applied the 2's complement, flipped the bits, added 1. And so then this piece right here, that represented our 247, which means that this number here is the negative 247. I guess after watching this, you're saying, oh, Professor Brower, I would love to do an architecture lab on this. Give us 2 sets of 6-bit numbers to multiply together. And with that enthusiasm, you can jump into the architecture lab.